Good morning, good afternoon, and good evening to everyone present here. I am Saurabh Sonwani, an early career representative of iLEAPS and the convener of this program. With me is co-convener Pallavi Saxena, a scientific study committee member of iLEAPS. We welcome you all to our 10th episode of iLEAPS Global Interview Series. Today, our guest is Dr. Garry Hayman. He is a land, surface, and earth system modeler at UKCH and a science officer in International Project Office of iLEAPS. However, before introducing him, I would like to say a few words about iLEAPS. iLEAPS stands for Integrated Land Ecosystem Atmosphere Processes Study. It is a global research project of future. It seeks to provide an understanding about how interacting physical, chemical, and biological process transport and transform energy and matter through the land-atmosphere interface. Like other future global research projects, iLEAPS is a network to link iLEAPS scientists to key societal challenges related to health, biodiversity, climate, food, and fuel security, and ultimately to the United Nations Sustainable Development Goal. It promotes scientific excellence through developing international science and initiatives that are multidisciplinary through bringing together the modeling community with satellite, experimental, and field observational experts, and through enabling communication and networking across the international science community. It facilitates such initiative by acting as a communication hub and coordinator of worldwide scientific research in the field of ecosystem atmosphere exchange and the impact of those exchange on key societal issues. Another very important initiative of iLEAPS is the promotion of leadership in science through capacity building in developing countries, as well as through their early career scientist network by hosting workshops, ensuring timely and relevant science to be available through their website and training program. Recently, we have conducted several programs at regional level, at the global level as well, like Earth and Environment Day series from 2021 to 2022, targeting South Asian region. And we have also organized iLEAPS Live Conference 2022, iLEAPS OSFlux Conference 2023. We have also successfully conducted a Global Curriculum Series 2022, 2023, 2024, and it is also running in 2025. So we are also very much active as a convener, and we organize several sessions in different international conferences like EGU and SRI from past few years, and recently conducted sessions in IGAC and SOLAS 2024. As we know that there are several challenges people face, especially the early career researcher face in their field, the respective field of science and technology. Thus, motivation is always required to drive the enthusiasm to carry forward the research. The key to motivation is just to follow the footstep and the journey of the renowned and esteemed researcher and academician that will help to identify their ultimate goal. So this understanding has been behind this present program to provide researchers, especially early career researchers, an opportunity to imbibe knowledge, inspiration, and zeal to conduct their research in a direction that is fruitful for their welfare and for the welfare of the science and society. So with this brief introduction of iLEAPS, this is time to start our program with our guest, Dr. Garry Hayman, who has had the remarkable journey in the land and atmosphere interaction, land surface and earth system modeling and earth observation. He is also an expert in atmospheric chemistry. So in bit detail about uh, understanding about Dr. Hayman, here I would like to request Pallavi to introduce him. Pallavi, now the floor is yours.
Thank you, Saurabh, for giving me the floor. So, our today's iLEAPS Global Interview Series interview is Dr. Garry Hayman, who is a land surface and earth system modeler with research interest covering land atmosphere interactions, lead investigator for projects on Earth system modeling and on peatlands. He has also been involved in research projects concerning methane to develop and evaluate the methane wetland emission parameterization in the Joules lab extensive background in atmospheric sciences with over 25 years of experience in atmospheric chemistry and air pollution issues. Garry received a Bachelor of Arts in Natural Science in Chemistry from the University of Oxford. He subsequently completed a doctorate at Oxford on high-resolution infrared spectroscopy of molecular beams. Garry has an active role in iLEAPS, where he leads the iLEAPS project office that is hosted at UKCEH. So we again welcome Dr. Garry, and we love to hear about his career life.
Thank you, Pallavi, for reading out the biography of Garry. So, and so good afternoon, Garry. Now we are formally proceeding with the interview, and our first question is related to your career journey. So please brief about your education, career path, and collaboration that you had to help you to do the role that you have now. So we love to hear you.
Uh, Thank you very much, Sarab and Pallavi. It's a great pleasure and honor to be asked to be a guest on this interview series. So I look forward to sharing some of my journey and achievements with you and hopefully give you some pointers. So in brief, Pallavi has already introduced me. So I grew up in the UK, where I developed at school an interest in science. That led me, as Pallavi has said, to undertake a degree in chemistry at the University of Oxford. This was a 4-year degree course with a research project in the 4th year. I was very fortunate to receive a first-class degree. I developed an interest in physical chemistry, especially spectroscopy and quantum chemistry. I stayed at the University of Oxford to undertake a doctoral research. I was awarded a doctorate in 1986 with a thesis on infrared spectroscopy of molecular beams, particularly of what are called weakly bound molecules or van der Waals molecules. So these are molecules between that I studied were between rare gases and molecules like carbon dioxide, nitrous oxide, or carbonyl oxysulfide. I was using infrared spectroscopy, particularly tunable diode lasers, and what we were doing was to try and stimulate vibrations in the triatomic molecule like carbon dioxide and try and record the vibration rotation spectra of the van der Waals molecule. That actually has its ups and downs, as most research did. Eventually I was able to record with the team spectra of a set of these complex weakly bound molecules, and was awarded my doctorate in 1986. That spurred an interest in research as a career, although probably not in that particular area. So through a network of tunable diode laser users, I happened to hear about talks that were being undertaken at the Harwell Research Laboratory of the UK Atomic Energy Authority. That was one of the organizations that I made application for a job. And I was successful in getting a position in the Atomic Energy Authority working on atmospheric chemistry. So I started there doing some laboratory studies. These would be like reaction kinetics, looking at species and the reactions of those species that occur in the atmosphere. And one of the very first projects I was involved in were the reactions of halogens, particularly the halogen oxide radicals that play a role in the stratospheric ozone chemistry. So it soon became a kind of very hot topical issue, because in the mid-80s we suddenly became aware of measurements from Antarctica which showed significant and severe declines in the stratospheric ozone abundance. So we call these the ozone hole, and it became clear that the work I was doing was kind of linked to the processes that were causing the ozone depletion. So it made the work, took it out of the laboratory and made it very relevant to the real world. It was a very exciting and fast-moving time as people was proposing theories, testing those theories. There was obviously, because of its big environmental significance, there was a lot of international activity, international meetings, and the kind of assessment reporting. So it was kind of a very exciting thing, got me very intimately involved in doing work, research, got me into environmental research, got me into an area of environmental research that was kind of very active and built kind of collaboration in networks. After that was one aspect of the work, but then I became more involved in tropospheric chemistry and air pollution. At the time, we were bidding into the European Union. There were a lot of projects that were funded. And again, that gave collaboration and network opportunities with meetings around Europe. During this period in the early 90s, I did a 6-month secondment to the UK Department of Environment, where I was covering and working on air quality. And that gave me fairly direct experience of science into policy, how science is used to inform decision making and contribute to policy development. At the time, my organization, the Atomic Energy Authority, was undergoing some major change. Part of it was split out and eventually became privatized. Our environmental activities were merged. So over the years, I kind of took on project management roles. I also then became a research director overseeing a portfolio of projects. A lot of this work was what we call contract work. We bid for work from the UK Department of Environment around air pollution and air quality. So over the years, I became involved in a wider range of environmental issues related to the atmosphere, photochemical ozone, acid deposition, and so on. Then I think I'd been with AA Technology for about 20 years. An opportunity came up for me in the UK National Physical Laboratory, It was to work on particulate matter, and that was kind of the key pollutant at the time. And that was quite an attractive opportunity for me. But that was probably relatively short-lived. In 2009, I decided to kind of take a change of direction, and that's when I joined the UK Centre for Ecology and Hydrology, initially working on Earth observation or remote sensing, and then gradually becoming more into land surface modeling using the Jules land surface model, land atmosphere interactions. So that's kind of a very brief overview of my journey. So over the years, I've developed networks and collaborations in atmospheric chemistry, air pollution, the Jules land surface modeling. That is the land surface component of UK climate and earth system models. So through that, I've become involved in climate and earth system models. And also whilst I was at UKCH, as we'll come to subsequently, I became more involved in iLEAPS. So I guess over the years, it's been fortunate that I've been able to attend a lot of to undertake scientific work that's of national and international importance, many opportunities for networking, going to meetings and conferences.
Thanks, Gary, for sharing your very inspiring career journey right from the graduation till the current period. Every step is very much inspiring, and there is so many learning opportunities are there. People, and especially the early career researcher, can learn. And as you have mentioned, so many things where there is a role of interdisciplinary approach are there. You have worked from the core of chemistry till atmospheric chemistry, environmental issues, and even you have worked with the energy sector, from government to NGOs. So there are so many things to learn, and so many experiences, especially so much of the research work that have been carried out by you. So I hope this is very inspiring things that you have shared. So as we know that recently you are very much active in the land and atmosphere interaction kind of the sector. So as an expert in the field of land and atmosphere interaction, what is your vision and contribution in the biogeochemistry? That is one of your core area.
So I'll start with contribution and then kind of give some ideas of probably vision. So I guess in terms of contribution, as I've got worked on land atmosphere interactions, particularly as it relates to atmospheric composition, and that brings me links back into my previous work on atmospheric chemistry. So here at UKCH, there was a lot of expertise in the group and teams that I joined on what we call the energy and water sectors. So I kind of use my interest more to work on biogeochemistry, the biogeochemical cycles. So the very first area that I worked on was to look at the modeling of methane from wetlands and bringing together how we could bring Earth observation data and other sources of data to kind of test our process understanding, but also how we could use that to evaluate the land surface models. I then moved in to look at the emission of organic compounds, biogenic volatile organic compounds that emitted from vegetation, a range of whether it's trees, shrubs, crops, grasses, and how that links to atmospheric composition very strongly. So my background in atmospheric chemistry has been very helpful there in terms of understanding how those emissions link into the Earth system. More recently, I've been looking at what might be seen as an atmospheric process, which is to do with deposition. That's removal of trace gases and aerosols from the atmosphere to the surface. And particularly, this has got a very much how we update the representation of those processes in the UK climate chemistry and Earth system models. So that's where I am at the moment. But there's a very strong emphasis linking with the role about how we're using measurements, whether they be from the ground or from aircraft or satellites, how we can bring those and use those to thing. And that's a really exciting opportunity, bringing together these different data streams. Building on the wetland methane work, and again linking into kind of more policy relevant things, there was a funding call in the around 2016, which was to inform the IPCC special report on warming of 1.5 degrees. So this was a very fortunate call. So using the wetland methane experience that I gained, we put in an application which was successful to look at what we would call uh, feedbacks from natural processes. So this was wetland and collaborating with people who worked on permafrost thaw. There were other applications that were using the same modeling infrastructure that we proposed. So we kind of collaborated with those and kind of probably jointly delivered our individual projects. So there was one on land use and warming of 1.5 degrees, how bioenergy crops or afforestation could be used as ways of removing carbon dioxide from the atmosphere. There was a further project that was looking at the role of methane. Methane's got a relatively short lifetime in the atmosphere, so methane mitigation is seen as an attractive option to buy breathing space, if you wish, while we tackle the more challenging issues around decarbonisation of our energy and industrial activities. So that was again was kind of a great activity. There were a range of people involved in this. My researcher on that project took a fairly active lead, very involved in that, along with some of the other early career researchers. So it was a very stimulating one with a range of people with different expertises. And the whole idea of that was to try and, again, use our understanding to say what we, to inform what we could around what were the remaining anthropogenic carbon budgets if we wanted to achieve global warming targets of 1.5 or 2 degrees of warming. So those led to a number of high-profile publications. The work was cited in the IPCC special reports, not only on warming of 1.5 degrees, but also the ocean and cryosphere and a changing climate. And it also contributed to developing, so separately I've been involved then through these activities in developing the JULES community land surface model. So what do I see in terms of vision? Well, as I say to a number of colleagues at UKCH, I think we're in the period now where land is kind of seen as a very central part of the efforts around climate change and its mitigation. How we achieve a balance of net zero greenhouse gas emissions around food security, energy security, and also biodiversity. So there's a very pivotal role here at this time for the role of land in achieving these different things. And it also all links to the Sustainable Development Agenda. So within that, there's clearly very much still a physical science research component there about understanding those fundamental land atmosphere interactions, understanding the feedbacks. How does the land system respond in a warming environment? How does it respond to changes in weather extremes? What about multiple stresses? So as we push the climate envelope, we've got a number of topical questions here. And then you could build it into what about the resilience of all these plans around reforestation or planting trees? What about how feasible is it for large-scale deployment of bioenergy crops? So there's quite a lot that I would say that still needs to be done. And then ultimately, we still need to pull that information through into our land and earth system models, which are the tools that we use to project the future. And I would also say, and I'll probably come on again, repeat this later, that there's obviously as we should see where where artificial intelligence, machine learning can help us become more effective in answering these questions. So that's
That's great.
my.
Yeah, that's great for sharing your very outstanding contribution. And you have already shared so many things that you have already contributed in the scientific domain. So from your research profile, we have segregated some of your very cited research work, and we are really actually interested to dig deeper into this context. So we have segregated three of your research publications. So I'll be reading here, and it would be great if you can put some light onto that particular research articles. And even though you have already summarized some of them, so here I'm just reading. The first one is research into land atmosphere interaction supports the sustainable development agenda. So that is the first one. And the second one is the carbon budget for 1.5 and 2 degrees centigrade target, lowering by natural wetland and permafrost feedback, that you have highlighted some of the points already. And the third one is increased importance of methane reduction for 1.5-degree targets. So these are the few research articles of yours for which we actually interested to listen.
Okay, well, the first one that you mentioned, research into land atmosphere interaction supports the Sustainable Development Agenda. This was very much an iLEAPS paper. So I led this particular perspective paper, which reviewed iLEAPS, its achievements since its inception in 2004. So the first 10 years there was a paper published in 2014 on the first 10 years. In a sense, this was a follow-up paper to look at the second 10 years of iLEAPS, some of its key achievements, and where iLEAPS was going in terms of its future directions. This was a paper that I led that was kind of largely involved the scientific steering committee of iLEAPS. So we kind of identified some future focus. So we recognize that iLEAPS is kind of stimulated the flux measurement networks across the world. It's stimulated those fluxes between the land and the atmosphere. And so we were kind of said, yes, well, that's an area that's kind of synonymous with iLEAPS. And indeed, our last Open Science Conference was held with one of the flux measurement networks, Ozflux, Australia, New Zealand. So we saw that as a area that would continue through our what we would call global change, looking at the carbon cycle, looking at those fluxes. As I said, land is a kind of a key area, so we see land use as being again one of those focuses. We know that industrialization, urbanization, those developments tend to lead to increased air pollution. So we see air pollution. And again, that's always been a kind of topic of iLEAPS. But we were also thinking around what we call novel entities, new pollutants. And indeed, one of those is iLEAPS is really taking forward on plastics and microplastics. And then there were some more broader ones about thinking around new technologies and new data analysis techniques and as I mentioned just in the previous answer around new methods, around use of artificial intelligence, machine learning, and how we build the iLEAPS community, and particularly most importantly, the early career researcher one. So it's about how we can reach out and support either through opportunities, being involved in the iLEAPS activities, providing mentoring, or just generally supporting that community. In terms of the second paper, although I have covered them, I think particularly this one is that what we know is that certainly wetlands, we know that in a future warmer climate, the methane emissions from wetlands will increase, and so there's a positive climate feedback. And similarly, as with global warming, permafrost, which is frozen ground, that will thaw. That becomes active, and then we get either, there's changes there about whether it can release carbon dioxide and particularly methane. And again, those could cause positive feedback. So the work we did there was to use the Jules land surface model within a kind of climate emulation system that enabled us to look at these kind of climate land feedbacks. And actually one of the innovative things we did there was to create a kind of inverse form of that system. So we could actually reach specific warming targets rather than just going forward and responding to the kind of forcing. So we wanted to reach definitively this. And what we showed is that if you include these feedbacks from wetlands and permafrost thaw, that would reduce the remaining carbon budgets by between 8 to 12%. And particularly as we are now probably only have like 3-ish years possibly for a 1.5 degree warming thing, then that's obviously quite significant, and it's kind of becoming a really live topic. I kind of briefly summarized the importance of the other one. I will link it into the follow-on paper, the synthesis paper we did there, which was to look at not methane versus land use scenarios, but to look at which would be the more effective option in different regions. So I would put together a paper there, which was to look at the regional impact of methane mitigation against land use. So there we are. Thank you.
Thank you so much for highlighting the very important context of the articles. Sticking to the first article, that is actually the perspective paper. So in addition to that, here we would like to ask you, as an IPO of iLEAPS, let us know about the history and the achievements of iLEAPS.
So iLEAPS was formed in 2004 as part of the International Geosphere Biosphere Program. A lot of the initial leaders of the iLEAPS project the community felt there was a gap between atmospheric chemistry and particularly needed a focal subject on these kind of fluxes between the land and the atmosphere. So iLEAPS was formed in 2004. 10 years later, the International Geosphere Biosphere Program came to an end. The projects that were in that program were then moved into Future Earth as a new entity. Future Earth had a broader remit. It brought in social science. It brought in biodiversity and human development. So there was a wider range of activities, really creating Future Earth, supporting the sustainable development agenda around sustainability research and innovation, with a very strong emphasis on transdisciplinarity. So in 2016, my institute, the UK Centre for Ecology and Hydrology, took over the hosting of the iLEAPS International Project Office. It had previously been in Finland and then in China. So UKCH has hosted that IPO, the iLEAPS IPO, since 2016. And I've been involved probably not long after 2016. So I've been involved in iLEAPS as part of the IPO since that time. Although I have to say I did attend the iLEAPS Open Science Conference, which was held in Germany in 2011. So I've been aware of iLEAPS for a while, but it's been really great and a great pleasure to be involved in this interesting and important activity, and looking at how we can pass the baton on to the next generation to take iLEAPS forward. So in terms of achievements, I mentioned earlier that iLEAPS was kind of very much involved in stimulating flux measurements. So we know that that's probably now very much established, and we have FluxNet and its kind of regional networks. iLEAPS initiated a lot of joint projects with other similar global networks. So, for example, the International Global Atmospheric Chemistry Program, IGAC. Through IGAC, we had initiatives on biomass burning. That's come round again. We're working with IGAC on biomass burning. We were also involved, although we don't get much of a profile for it, for the global emission inventory activity. There's other ones that I could mention around the aerosol clouds, precipitation and climate, which is links us into some of the World Climate Research programs activities, particularly its Global Energy Waters Exchange project, so GWEX. We've had open science conferences. We've had successfully hosted 6, often in collaboration with other partners. So we've got a upcoming conference in Japan in 2027. I mentioned publications, so there have been a couple of key publications, the perspective paper that we discussed earlier. We're building links increasingly with other networks, both within and outside Future Earth. And I think the SSC members are contributing to high profile activities. So I think it's about using the opportunities, using our expertise, trying to raise our profile and raising our impact. And I should add, we have a very active, or we did have a very active early career research network.
Thank you so much, Garry, for sharing so many things about iLEAPS, its history, its achievement, its collaboration, international presence in the community. I hope iLEAPS will be achieving new milestone in near future by promoting ECRs, research in the domain, by collaboration, and by introducing new opportunities. And we are really very excited for upcoming conference of iLEAPS to be held in Japan in 2027. So thanks for sharing in a very detailed way. So moving forward, here we are also interested to just listen about that about your greatest contribution that you understand that yes, that can be considered as the greatest contribution of yours in the field of science or society. So yeah.
Okay, so I guess in science we live and breathe by publication. So obviously I have a range of publications, maybe not as many as one would like, but nevertheless some have been quite high profile journeys, so that's always very good. I've obviously been very much using science in this kind of environmental space about how it contributes to society. So I guess getting the papers cited in assessment reports and thereby informing policy. And I think to some extent, I would also like to kind of feel like I've contributed to the development of ECRs. I have supervised 1 or 2 PhD studentships. I was kind of promoted where appropriate early career researchers, particularly the researcher that I mentioned. He led the paper that was on our wetland permafrost feedback. So that was Eddie Coman-Platt. And also I think within iLEAPS, I think I was at least proposed and got it endorsed that we formalize the link with our early career research network by having an ECR representative on the main iLEAPS scientific steering committee. In terms of society, as I say, most of it is about contributions into the WMO, the stratospheric ozone assessments, the IPCC for climate, those reports. So I contributed around the replacement chlorofluorocarbons, the impact of aviation, and also was a review editor for one of the chapters in a report that was looking at the implications of stratospheric ozone depletion, compounds that contributed both to stratospheric ozone depletion and to climate change, because in essence they were under different UN bodies, and so it was trying to try and identify those opportunities where we could get a win-win, if you want, for both stratospheric ozone depletion and also global warming. And I guess through all those contributions, I was part of the IPCC community that shared the Nobel Peace Prize in 2007. So I do have, although I have to confess that I haven't got it framed yet, I do have the certificate acknowledging that. So that's obviously really pleasing to see that acknowledgement in there. And within the UK, I think there are contributed to kind of assessments around transboundary air pollution and also ground level ozone. So yeah, those are what I would see as my main contributions.
Thank you so much for sharing this. Some of your greatest contribution. The replacement of CFC is really commendable job, and obviously the having the Nobel Peace Prize in reference to that IPCC contribution in the through your research, and so I hope this is so many things through which we can learn a lot. So moving ahead, we are also really interested in the project or research work in which you are currently working, and um, the thing that you actually wanted to highlight that yes, this is a really important topic, and people can consider for the future research into that context.
So I'm just going to probably what I'm currently working on is I lead for UKCH two projects, two large multi-year projects. So one is our UK Earth System Modelling project that brings together the UK Meteorological Office along with other research centres that look at the other Earth system domains, i.e. the oceans, the cryosphere, the atmosphere. So UKCH brings the kind of land expertise into that project. So this is about developing the UK Earth system model. So this is like climate chemistry, but we have a lot of the biogeochemical feedbacks. So we're looking then at producing a as comprehensive a model as we can of the Earth system and to use and apply that. So that model will be the contributes into the kind of the CMIP thing. So there's a big modeling exercise with every IPCC assessment cycle. So that model is the UK contribution into that program. Although I would have to say I have not a direct role in that, but I'm just saying that's where it goes. But I am contributing to the development of the land surface model. So the work I was doing on atmospheric deposition, that bit of coding will be used in our next generation Earth system models. So I can kind of say, well, I have contributed to the development of the model, but maybe not so much to its application. The other area that I will focus on is another project about developing capability in our Jules land surface model, but it links into work around peatlands. So peatlands are a major store of carbon. Both in UK and Europe, we've converted peatlands to agriculture over the last 200 or so years, but there's a lot of interest. So that means that those agricultural lands are now a source of greenhouse gases. So through peatland restoration, converting where appropriate land back to peatlands, we can take up carbon, and therefore that acts as a kind of natural nature-based solution, if you wish, to drawing down carbon from the atmosphere and storing it in the land. And it's about developing a capability to model peatlands in the Jules land surface model, which it currently doesn't have. And in time, that would feed through into our kind of Earth system models. So those are the projects that I'm in, and I think you probably see both have relevance to society, because again, it's about informing through the Earth system modeling work. It's about where we are in understanding global warming, climate change, what we can do about it, what are the feedbacks in the Earth system, and are we at risk of things like tipping points? And in terms of peatlands, a very important store of carbon. How resilient is that under climate change? And so, is it a good, secure, long-term store for carbon? So, yep, that's where
Yeah,
I'm doing at the moment.
yeah. Thanks. I hope this research will be really very helpful for the researcher and as well as for the society, and it will be really helpful for the policymaker, the land use planner, and the people working in the climate change research, especially. So, uh, as we were considering or we are listening about the SDGs and sustainable agendas and sustainable futures. So, keeping this in mind, we are just considering that since you are a very having a very huge experience in the field of land ecosystem and atmosphere interaction. What is your vision and plan to achieve? What you want to suggest uh, to achieve the sustainable future? What should be the plan of
This
action?
I'm going to keep it very much focused on what we can contribute rather than trying to get into the kind of broader geopolitical issues around this, which are obviously clearly significant and challenging. So I've been head of the IPO since 2019. I think that puts, as part of the IPO, I'm in a privileged position. Is this kind of node to link to Future Earth, other global research networks in Future Earth, and other international programs. So the vision, I think, is to some extent encapsulated in the perspective paper that I led in 2024. We've already got things around global change, land use, air pollution, novel entities. So it's about understanding how we use land, how we're impacting on the natural world, or even where we're offending, and how our activities are contributing to the various issues that we face. So that's where I would say that the vision is there. I think we're in, as we would say, we're doing research. iLEAPS, I should say, is doing research that on the physical science of these systems, but linking into other actors who are more involved in the societal aspects. But we're looking at these crucial questions around land use, food security, water security, and to some extent energy security in terms of things like bioenergy. So I would say that this is an exciting and good time to be involved in these areas. How we're going to kind of deliver this is really through, particularly in iLEAPS, we're looking at setting up and running these working groups. I see other networks have similar structures, and I think it's through these working groups that we're starting to set up on microplastics pollution, where we're working with the International Global Atmospheric Chemistry. We're working with the Surface Ocean Lower Atmosphere Studies SOLAS. So that's one area. We're working starting to build up something around deposition, which really brings together multiple Earth system components, the land, atmosphere, oceans. So we're working there again with IGAC and SOLAS. And then I think there's other ones that we're starting up more about remote sensing, and that will bring us hopefully start to interact with maybe like the Global Carbon Project, other areas like arid areas, drylands, elevated regions. So I was last week involved with the GWEX glass panel meeting and talked about some of our activities and how we could collaborate. And so it's by building those relationships that we deliver. And what I would also say, and I think there's a lot of opportunity now to refresh and bring in early career researchers into these activities. So I'm very keen as part of the IPO that we do bring in early career researchers into these working groups to bring their experience and voice and see it as a development opportunity. And one thing I would have said in referring to the work I'm currently doing, I don't do all the work. A lot of the work is being led by early career researchers. And I think it's about acknowledging that contribution and making sure it's recognized.
Thank you so much, Gary, for highlighting such important thing. The next, the upcoming question that was in my mind, so that was actually related to the upcoming topics, the topics that are actually lagging in the field of atmospheric science and climate change and ecosystem related domains. But I think many things that you have already covered, that you have already mentioned so many things related to this question also. So if you want to highlight some more point into this, then it is fine. Otherwise, we can move ahead.
Well, I'll give you some very quick ones because obviously, as you say, I have covered quite a lot of this. I mentioned for ecosystems, I guess it's resilience of ecosystems to climate extremes, multiple stresses, wildfire. Probably in the modeling set, there's a lot of measurements we could do, but in the modeling sphere, it's around the spatial scales and what we call heterogeneity. How uniform is the grids, the grid cells that we use? You know, how much heterogeneity or how heterogeneous is the land within each individual grid cell? And there's urbanization, so we know that certainly more than 50% of the world's population it lives in the urban environment, and so there's urbanization. And what does that mean, particularly for the I don't know if the developing countries is the right word these days, but obviously the global south. In terms of climate change, obviously there's a lot of work there. We're moving probably from understanding the kind of physical science more into adaptation and mitigation. I've said a lot around land use and net zero plus, lots of opportunities there. And then I guess that links into something that I was involved in only last week, which was about carbon dioxide removal. And you might say more contentious climate interventions in the Earth system. You know, these are probably known as things like geoengineering. So there's a lot of work still need to be done there about what is the efficacy of this? What is the ethics of it? How should it be, if it should be deployed, how should it be deployed? And so on. So I think there's a lot of, still a lot of work within that kind of thing. And atmospheric sciences, I guess some of the things again linked is, why is methane and also carbon dioxide, the recent growth rates larger? Is that some signal there? And also, I think there still seems to be, we have an understanding of tropospheric chemistry, but there still seems there's more to do. And I can link again, make the points around tools, new analytical ways of doing things. So again, how we use machine learning and artificial intelligence in that.
Thanks for highlighting the important but the lagging area in the field of atmospheric science, climate change, and ecosystem. Now coming to the end, this is one of the favorite question. What is your message to young scientists working in the field of land and atmosphere interaction and climate change? What do you want to suggest them?
So what I've kind of probably just put a few bullet points. I think I've kind of stressed throughout this when we've been talking about land atmosphere that land is important for achieving climate targets, whether it's the Paris Climate Agreement, whether it's net zero plus. The work is significant and of societal relevance. We've got great opportunities. There are data, models becoming open source. That there's a lot more opportunity to use these quite sophisticated and complex tools to provide insight into things, particularly where maybe particularly where regions that are maybe less well covered with this in the past. We might want to see how satellite observations could be brought in. And then I would probably just say a general one that iLEAPS has a very an active early career researcher network. So I would say get involved in that, reach out. We're a very welcoming community. We want to bring you in and build, and that's a great way for you to kind of build your networks, meet people from working in land atmosphere interaction with a common interest, build collaborations, a great community, a supportive community. So there's a lots of opportunity. And again, once you've kind of got some work established, I think there's probably a starting to be trying to bring in more early career researchers, get their voice more heard in some of these big international assessments. So I think that there's a lot of opportunity, and I'm sure others that we can get you involved in through the opportunities that iLEAPS has, through the contacts that we have, the opportunities we receive from the wider Future Earth community and opportunities. So I would say there's a lot there. That's my advice. I probably, on my career, I don't think it was probably as well planned. Although I probably wouldn't say I kind of had a kind of a vision when I was a 20-year-old about where I wanted to be. I've kind of very much enjoyed what I've done, how it's contributed, and I look forward to kind of seeing how I can help the iLEAPS community grow, and particularly the early career researchers.
Thank you so much, Garry, for sharing a very huge experience, and thanks for inspiring so many early career researchers, especially. And all the suggestions, your research experience is very much helpful, very much relevant, and it will be really help for all of us, all the early career scientists to achieve the different goals in their career. So now we are coming to the end of this program, and here I would like to ask Pallavi for her remarks and vote of thanks.
So before you do that, let me just say thank you both for the opportunity to give this interview. and I really wish everyone well with their future and good luck in whatever you do. So thank you.
Thank you.